Okay, welcome everybody. Today we're going to continue our look at software quality assurance, and we're going to be looking at a particular topic that's very relevant to software quality, which is process. This is kind of the first lecture on software process, and the majority of the time when I talk about process in the course, we're going to be talking about agile processes and agile development. But I do think it's good to put it in context. And I know some of you probably have seen in other courses about different software process models before. So some of this may be a recap, but what I want to do is I want to talk about in the context of software quality. Because one of the things, there's a couple of, things that you can think about when you're trying to provide a quality product, right? And let's just say you're talking about your measure of quality is bugs. It could be, there are a lot of measures of quality, but let's just talk about bugs just to simplify things. One way to ensure less bugs is to actually do the requirements properly, do the design properly, do the programming properly. Another way is to actually have really good quality assurance, like testing and analysis techniques, so that after it's written or after the requirements are developed or whatever, that you can find all the mistakes, find all the bugs. So it's sort of like, do you want to, you can focus your efforts on, preventing bugs from happening or on finding them when they do happen. But the reality is that you actually need to do both. And also in reality, it's more than about bugs. It's about a whole variety of things, such as, do you meet the right requirements as seen in this cartoon? Or do you have the performance? Is it available? All these other things. And so in general, that's sort of what we're going to talk about today is software process and how it relates to software quality assurance, which is how does it relate to actually, ensuring that we actually produce higher quality software with less bugs and which meets the requirements and so on. Just see a quick question here in the chat. I already mentioned this already. Lecture recordings are going to be posted after class. In this case, last lecture is in the process of being processed, and the YouTube link will be posted to the course website after class today. There are no readings in advance of this. I do have some short videos that I'm going to ask you to watch before next class. What we're going to talk about today, though, is we're going to actually talk about process more in general as it relates to SQA. And then in the future lectures, we're actually going to devote a couple of lectures where we're going to look at agile development methods. And part of the reason we're going to be looking at agile is because agile is actually what we're going to be using in our course project. So we're going to actually spend some time looking at some different agile techniques. And you'll see that a little bit later. That includes Scrum and includes something called Kanban. And we'll also talk about a little bit of an older one, extreme programming as well, because I think there's some good practices in there. But for today, we're not going to talk about the agile. We're going to talk about traditional software process as it relates to QA, because I want you to understand the context of the things you have to think about when you're doing the agile development techniques. So, what we want to talk about a little bit today is we're going to talk about that relationship between software development practices, software process models, and software quality assurance. There are a variety of different approaches to how you develop software that are used in the community. And really, a lot of it is contextual. What's done in a certain company, in a certain industry, what's required, and sometimes by regulation or standards. And what we want to really focus on, though, is less about what's going on in the development process, and I want you to more focus on how do we assess the quality of that process. The other thing that I want to do today is I want to get you thinking a little bit about your own practices and your own things you do and how you could actually be sort of figuring out, am I doing the right thing? Now, speaking of doing the right thing, let's go back to the very last thing I briefly asked you to read about last class. And that was the 3 principles of software quality assurance. Does anyone remember what the first principle is? Know what you're doing. Right. So you need to have a way of measuring and knowing what it is you're actually, so to understand what it is you're doing. What are the practices you're doing? What's the process you're following, and so on. What's the second principle? Know what you should be doing. Exactly, right? So there's sort of like, okay, this is actually the practices that I'm doing. What I'm trying to do is, maybe it's Scrum. I'm trying to do Scrum. This is what I'm doing. This is what the ideal of what I want to do. And then what's the third principle? Know how to measure the difference. And this is where things like the metrics come in. And what you want to be able to do is you want to look and say, okay, this is what I'm doing. This is what I should be doing. How can I measure the distance between those two? Because the goal here is, if this is, let's say up here is what you're trying to do, and this is what you're doing, what you want to be doing is if you look at the difference in terms of the measurement, the metrics, is as you go over time, you want your techniques and your process to be moving up and reaching that line of your goal of where you want to be. So this is what we talk about when we talk about continuous improvement, and we talk about the idea of using metrics to improve SQA, right? It's not that, you're not sort of stuck at, well, I'm doing this and my quality is always going to be this. Your quality can fluctuate. And what you want to be doing is you always want to be doing things, assessing, understanding, so you can improve and reach your maximum potential when it comes to SQA. So, and those three principles are very important, so I encourage you to remember them. Okay, so a little bit about development process, and I don't want to go through this because, to be quite honest, development process isn't one of the most exciting topics. But I really, this sort of serves as the foundation for the more industry-focused discussions we'll have about Agile. Basically, in general, every software development process is some organization of all the kind of standard steps you take when developing software. And the reason we have process is because as software systems, like if you think about it, when it started out with just, one person writing some code, like, I'm talking about like way back, like, you might have like punch cards, right? Or you have a shared machine where you write a little bit of code, you go try it, you go take it back, you fix your bugs, you fix your code, you go get the machine again, you try it again, and you have this iteration. It was when you're doing something at a small scale, it's a lot easier to do it without really having to worry about the process. But as things get bigger, as more people get involved, you often have to kind of put some management structure in and some way of organizing, or else things kind of get chaotic, right? A great example of this is, think about when you're in a course yourself. If you're working on a project where there's only one of you, right? You're the only person. You can probably keep track of what you're doing, maybe in a notebook or even just in your head. But the moment you add more people, it gets more complicated. If you're doing a project with one other person, a little more work. You have to keep track of what the other person's doing, what you're doing, and there are going to be times where you need to be synchronized, and they need this part of that you're doing in order to do their part. If that project involves 3 or 4 people, there's more work to do. If that project is a 10-person group project, have you ever had to do a 10-person group project in your courses? Yes? Wow, that's great. What about 20? No. How about if I just gave this whole course just one group project? That would be intense, right? And the point is that I wouldn't be doing it to try to make you fail. I'm just doing it to raise the point that as that scales up, there's more work involved, right? You can't just you can't just rely a little bit on informal stuff. So you need to have some way of actually organizing the tasks and understanding, because everybody's work is relying on other people. So that's what we're talking about. And if you have control of the tasks, then you know what you're doing, right? Like if you understand the tasks you're doing, I first have to get the requirements for the software. I then have to design it. I then have to, write it, whatever it is. You understand. So if you can kind of do that, then you're kind of at principle 1. And in general, every software process model that you look at, whether it's the oldest, most traditional model to the most cutting edge, popular today agile technique, they all have the same activities in them, right? There's a specification step, and that's where you actually figure out what are the requirements, what should the software do, what features does it have, and the constraints. Does anyone know what I mean by constraints? Could be memory size and stuff. Yeah. So one constraint could be, you know what? I want you to develop this app, a travel app, but it has to. One constraint is it has to work on Android, or it has to work on any Android device manufactured in the last 5 years, or these are the server constraints we have. Sometimes, though, constraints aren't about hardware. Constraints can also be about limitations. So, for example, let's say that if I was a web development company and we were developing something, if I don't have in-house expertise on a particular technology, I might end up using, like, if I only knew about one type of database and nobody knew about another type, I might be constrained by the knowledge and expertise of the developers I have in my company, right? Like, if everybody knows C and nobody knows, Scala, I'm not going to be like, well, we're going to write a program in Scala. We're going to write our app in Scala, right? Because we don't have the people. So the constraints can also be sort of constraints on the limitations that the company has. It could be one constraint is it has to be done in, deadlines. It has to be done in 4 months, or you only have $50,000. Right? These are kinds of things that could be constraints, and that's part of the spec, right? Because the reality is you do not have unlimited resources to do this. Yeah, and that's lack of employees or employee skills is falls under the constraint. So all of this falls under the specification. You have to plan with all of this information in mind. Okay, so once you know what you're doing, you know the requirements you have and the functions of your software, you know your constraints or limitations. You then have to actually develop the software, right? You have to build it. And building it means meeting the spec. So the development usually involves several different things. It can involve design, right? Where I say, okay, well, it's going to have these components. This is the architecture. This is what's going to do what. And then the other thing is that once you design it, then you also have to build it. You have to write the code for it and so on. And then after you actually develop it, or while you're developing, you also need to have some validation, right? You need to have some way of actually checking, hey, does this do what the customer wants, right? Is what we've actually built correct? Does it meet our spec, or does it meet our customer needs? And then lastly, you need some way of actually doing evolution, which is the ongoing maintenance of the software once it's deployed. So once the software is out there, there's no software that I know of that, or I guess there are examples, but they're not less than ideal. But the majority of software has bugs. It has evolving requirements, changing requirements. So at some point in the future of this software system, you're going to need to update it. It might be that you're updating it, and it might not even be because even if it was bug-free and the functions never changed, guess what's going to change? Things like the hardware, right? The APIs that it uses might change. So even if you have foolproofed your software where it's not going to need to be maintained, your software depends on other things such as the underlying OS and platform, the device, the libraries, and so on. So in the end, you're going to have to actually think about evolution as well. And every process involves these 4 steps. So far, doing these steps, though, has nothing to do with quality beyond you just have an idea of what the kind of activities you have to do. The oldest model for quality assurance, and this is sort of, and I'll tell you where this is useful and where it's not, and it's not widely used now in industry, except in certain cases. But the first sort of real example of a process model is what we call the waterfall. Have you guys heard of waterfall? Yes? And I see someone said, wasn't this considered an obsolete model? Yeah, you know what? It's not. What it is, though, is it's a model that we understand has much more limited context. So where waterfall is still really applicable is in industries where they have really well-defined requirements up front, where they're building a monolithic type of system. So sometimes in cases of some government or military applications, waterfall can still be highly effective. But for most of today's reality, when you have evolving requirements, a need to get things out quickly, and so on, you're going to end up using something other than waterfall. And the idea with waterfall is you have these cascading phases, and every time you finish a phase, it's their sign off. And it's, there is an example here I have of IBM had back in the day IBM is an enterprise type software company largely. That's what they were doing back when this was around, and they do a lot of enterprise still. What they would do at each stage is they had something called ETVX, where every one of their stages would have an entry into that phase of the waterfall. They do the task, they'd validate they did the task, and they'd exit from it. So that was sort of every stage had that little 4 steps inside the phase. And this is what it looked like, right? And you might notice this diagram I got is, actually I pulled it from a textbook and I deliberately left this diagram at this year because this hasn't changed, right? This is still this was 25 years ago, and there's not much different in terms of the waterfall. And I just want to point that out. In general, this is the only time we're going to talk about waterfall. It's never going to come up again in the course. But it's important to know historically about what's been done. When people realize that there were limitations with this and that, well, what happens if, you get to the design and you realize in the design, hey, wait, I've got a requirements problem. Well, in the old waterfall, like in the first one, there's no way to go back, right? The only way to go back is when you're completely done. You could start the process again. So they built what we call an iterative waterfall, where at any stage you can go back to a previous step if necessary before cascading down again. And that's more realistic to what happens in practice, right? That traditional waterfall model where you never can go back is really outdated and is obsolete. What I want to point out, though, is that in each of these phases, the thing that this is useful about this is that it's actually very, it can help us to understand a little about quality. And in that requirements phase, one of the things we can do to ensure quality control when we get requirements is we can do what's called a requirements review. And that's where we have experts, other members of the team, just like you can review and inspect code, you can review the requirements document to see if there are mistakes. Are there things that, inconsistencies? Are there things that don't make sense? So you review these documents. You don't just write them up and blindly pass them on to be implemented. You have to review them to make sure they're correct. That's what we mean by a quality, ensuring quality in process, is building in activities that actually evaluate and ensure that what you've produced is up to a certain standard. And if you do these kinds of things, the quality control mechanisms, you're going to produce higher quality software, hopefully. In terms of the design, you do a design inspection or review. Exact same idea where you review the design. The design one would be looking at different things in the requirements, but it has similar goals. In the design one, you would also be looking at, does the design meet all the requirements? You'd also be looking at, especially about things like if there are any non-functional requirements, you may be looking for bottlenecks in the design or issues with the design that may limit how easy it will be to maintain in the future, that kind of thing. Things like, if there's a key point where if this component breaks, everything else in the system stops working, then you may say, well, if redundancy is important, that's a bad design, right? So those are the kinds of things you'll be looking for. With the implementation, the coding, you're really using testing there. And unit testing is when you test an individual block or piece of code, typically a function maybe, or a class or method. And that unit testing, that's what the individual developer does. So I test my own code that I write. I unit test it before I merge it with other code and see if it works in the larger system. Lastly, once we have the code, all the units written and put together, that complete system is tested at different levels, including system testing, integration testing, and acceptance, which we're going to learn about later. So these, you can see that every phase here has a quality control. And that's the thing that I want you to see from this. Not that the waterfall model is really great, but that it has these built-in controls. Because even when you do agile, you need to have quality control. And in the case of the maintenance and operation, which is the evolution after it's been deployed, the main thing you'll see as a quality control mechanism is something called regression testing. And what that is, it's really about making sure that the software doesn't regress back. So if you think about having a chain of every single version of your software, version 1, 1.1, 1.2, and so on, every time you make a change to that software, right, what are you doing? You're actually updating the code to fix a bug, to enhance and do a feature, to maybe improve the performance, whatever it is. You're making that change from version 1.1 to 1.2. When you make that change, you want to make sure that the new change, the new code works. But what you also want to do is make sure it doesn't break anything in the system. So that means that errors and that you fixed in previous versions don't reappear. So the regression testing ensures that we don't regress the software back to a state where it had certain problems. So we make sure that we don't have the old problems come back. And that's what regression testing is about. And lastly, you retire the software and decommission it. Does anyone know of an example of when you would decommission software? Has anyone ever seen that? So here's a good example. You can old Windows versions, right? There comes a point when Windows, a certain version, they say, you know what? We're no longer supporting this. So when they no longer support something, that means there's no longer going to be any security updates. It's, you could still keep using it. So it's been retired, but they really want you to move to the next version. Apple does this, I think, with OS I think they have updates every 6 years. Now, the thing about Apple is that they still allow you to use that software, right? You can still continue using it for a certain point, but gradually other software will stop working with it. A good example, Google actually does do retirement or decommissioning of things. They tend to sometimes will say, you know what, we're going to stop this product. Like they used to have something called Google Code, which was around just a little bit before GitHub. And it was very popular. Like we used to, in my research lab, post all our code on Google Code. And then they decided we're not going to do Google Code anymore. So they just stopped and they said, okay, you need to download all your code by this date because you won't be able to utilize it anymore. And so they just sort of end the product. Another example is, anyone know the company BlackBerry, Canadian company? They were famous for being one of the first, if the most popular, I guess, first smartphone company, right? With the keyboard-based smartphones. There are still people who use it, right? I mean, I think in Ontario, our premier still uses BlackBerry. I'd read online, and although the versions that are out there now, most of that the devices they no longer have security updates, but they've still worked. Well, as of now, BlackBerry's announced that they're actually shutting down the back-end servers for the BlackBerry services. So those older phones that they're moving to just being a software company, not a software hardware company. So now, beyond just no longer providing security updates for these for the BlackBerry phones, they're actually shutting down the back-end servers, right? And that's basically a decommissioning. So essentially, the phones will be largely bricked. Some local stuff you'd still be able to do, but for a number of things, you just can't use them anymore. And this is something that's becoming more common, and it's something that is a risk with smart devices too, right? Because with smart devices, you often rely on a cloud-based service, and if the company goes under and shuts down the cloud, your smart devices are not that smart anymore. So retirement decommissioning is something that's very common. We don't always think about it, but it is part of the process. Probably gave you more than enough examples of that. I don't know what that is, but if it's getting shut down, it's probably similar. Okay. So here's the reason why Waterfall fails and why people don't really use it anymore. Because I think it's important that you understand why older methods didn't work to understand why new methods are beneficial. So with Waterfall, things that are bad, or not bad, but things that are challenging with it include the fact that with Waterfall, you actually have it's basically what we call early freezing. So that means that what you do is when you finish a stage, you're done. So let's take, for example, requirements gathering. Well, in Waterfall, because requirements gathering is the first phase, when you're finished that, someone signs off and says, yep, you've got all the requirements you need. Move on to design. Well, in reality, you're prematurely freezing them, because often when we do design, when we do implementation, what you end up doing is you end up finding and realizing, hey, I made a mistake in the requirements, or, oh, we left something out, and you want to go back and fix them, because requirements can actually evolve sometimes, right? They can change. What the customer wanted 3 months ago may be slightly different than what they want today. So this premature freezing or early freezing is a big challenge with Waterfall. It isn't adaptable to evolving requirements, evolving changes in software. Another thing that it does is it inflexibly partitions. The idea that I do all my requirements before I do design, before I do any coding, before I do any testing, it really doesn't make a lot of sense from a developer perspective. It makes a whole bunch of sense from a management perspective. If you're a business manager, you're a product manager, and it's really nice to be able to say, hey, our requirements are done, we've met that target, right? If you are, it shows, it sort of gives you this feeling that, hey, I'm actually making progress. And so management tends to really like it, whereas developers tend to dislike it. So that's one of those other things with Waterfall, why we don't use it. As I mentioned before, that one of the challenges is this early freezing in Waterfall. And one solution to this is do something called prototyping. And prototype model is basically a solution to this issue that, we don't always get the requirements right at the beginning, and sometimes we have to evolve them and they change. So because most of the problems with Waterfall traditionally were failures of requirements gathering, meaning that the requirements were either wrong or inadequate. Often they were missing, right, or misunderstood, or they were changed over time. Prototype model tries to basically address this issue by building a partial implementation or a prototype early in the process that allows for feedback on the requirements and allows them to be redefined. And this is what it looks like. So in a prototype model, we sort of still have the traditional waterfall down at the bottom in the full-scale development. But before we get to that, what we do is the requirements gathering has this little design loop where we do a quick design, build a prototype, evaluate it with the customer, refine it, quick design, prototype. And we can do this until the customer is satisfied that the requirements are correct. So this is actually a variation on our waterfall, where instead what we're actually doing here is we're doing a little bit of a prototyping at the beginning. So we're doing this sort of refinement, iterative refinement. Does that make sense to people? Feel free to ask questions, because if you find that it's a question you have might engage and might make things more interesting. Okay. And in terms of this prototyping, I just want to mention here, so in general, again, every phase has to have a quality control. I'm only going to point out sort of the ones that we're talking about that are new. So the requirements is exactly the same as with Waterfall. The quick design that we do before we build a prototype, the quick design, the quality control is that we test the prototype, right? We build this prototype and get customer feedback. That's how we actually can refine that initial design. The prototype itself, it's funny, we usually typically, because what happens with the prototype? What do you do with a prototype usually? Dump it. Yeah, you discard it, right? The prototype is not, because I can do a prototype. I could do a paper prototype or a mock-up in PowerPoint of the design of a system where I build in links that go to other slides, right? And it just demonstrates the external interface for the user. It doesn't do anything, right? So often the prototype is something you just sort of trash. So because it's not kept, you typically don't worry too much about the quality control of the prototype because its intent is not to be something that's maintained. Whereas the design you choose or you create is going to be used in the full development. So the design needs to have quality mechanism because out of this iteration that you do, that this loop you see here, it's the design that gets maintained and kept and passed on to full-scale development, not the prototype. So the prototype, you don't really care about the quality. The design, you do. Is this considered a waste of resources? Definitely. That's the downside of it. And then the customer evaluation is sort of a evaluation inspection. So the customer inspects the prototype to see if they like it. And then the design can be reviewed and so on. And then you do the traditional full-scale development. And one of the big drawbacks, just as was pointed out in our class chat, is that there's wasted work, right? If I'm building multiple prototypes that I'm throwing away or discarding, right, in order to speed up the iteration, like that's work that I could have been putting into the actual software, right? So this is problematic. Another issue with this is inadequate or incomplete prototypes, right? It's often very difficult. If you're throwing away the work, right? What's the incentive to do the prototypes really well? To get the design, yes, but that means that people will most likely take shortcuts on the prototyping because they know it's not being kept. And to do these full prototypes of complex systems is often difficult or impossible. Therefore, often what they do is they prototype what they think are the essential parts, and sometimes there are certain parts of the software system that aren't captured by the prototype because maybe they're not outward-facing features that the user sees or whatnot, and those can get missed. Like, for example, if you had, let's say you were building a new e-commerce system for Amazon. Well, Amazon, one of their big things is high availability, because if their system goes down for like 2 minutes, or guess how much money they lose? A lot, right? So they want to be like, any time that system is down, they lose money. I'm not talking about their cloud server stuff. I'm talking about their Amazon.com.ca website. So if you're building a prototype, how are you going to build a prototype that captures the idea of always being available so that the user can see it, right? That's something that's really hard to incorporate into that design. So it's something that, requirements related to that could get missed. The last thing is that there's no, it's not like you build one prototype and you stop, or you do it 3 times and you stop. You can keep iterating, and if the customer, especially if the customer doesn't know what they want, and the design team or the lead of the development doesn't know how to encourage the customer to stop, or to sort of, I guess, to end up making a decision about certain things, you can get this constant iteration loop, which is called creeping excellence, where every iteration of the new prototype, there's something else they could improve. And at some point, they might get back and where they've changed features back to what they had in previous. So you can get this, what's called creeping excellence, where it's never sufficient, and you don't want to waste your time with that. So, given these problems with prototyping, the next, I guess, evolution, or the next phase, or the next sort of idea about process that was developed was what's called evolutionary development, or prototype evolution. And the idea here is now it's like, let's harness our prototyping in a way that allows us to take that work, and rather than discard it, let's actually evolve it into the real system. And let's take advantage of the notion of creeping excellence, where we want to continuously improve to get to a new version of the software, or a full version. So now, if you think about here, if you have this initial version right here, let me see if I can. So if you have this version right here, right, this initial version, this would be your first prototype. Well, what you're going to do is as you go through development here, you're going to gradually, over time, you're going to actually get to the point where you have a full version of the software. That's the goal. And in between that, you're going to create a whole bunch of intermediate versions that will gradually over time, as you go through the loop here of spec, development, validate, spec, development, validate inside here. So as you kind of go through this loop, you're going to continuously create versions and end up with a full version at the end. Now this is starting to sound like, hey, this could be useful. This could be something that's beneficial. And that's something that we might want to think about. And in this case, the goal is to never leave the prototype iteration until you're done. So forget about full development. We're just going to do the whole thing in that loop. And then once we're done, have the full version, then we're done. And oh yeah, I should mention, which I didn't, is that these things can all happen concurrently, meaning at the same time. So while one group is speccing out or developing or validating, like I could be validating one version, I could be validating part of this while somebody else is developing a different part or speccing. So I just want to mention that. So we're getting to a point where maybe this is useful. But the thing that I want you to take away from this is this notion of iterative, right? This evolutionary. This is getting now more in line with the principles of agile, which we're going to see, where we do have this iterative process. And the nice thing about this is you get a version of the software sooner, right? Unlike with Waterfall, where the first version of the software you get is at the end, this, you're now getting an initial version followed by a full version later. Now, one last one I want to mention, and I'm mentioning this not because I think it's something that is really applicable for what we do, but it's actually a meta model that's been added on top of a traditional software in U.S. government projects to ensure quality, and that's something called a spiral model. And a lot of government agencies still do use spiral model, although it has become less common depending on the type of project. But basically, the idea here is that if you think about every loop around this spiral from the inside out, every loop around you can kind of think about as a phase of development, right? The inside one is about requirements and the outside one is about testing. And at every one of these sort of phases, similar to like how the IBM had their sort of four-step process for each phase, well, the spiral model has 4 steps that you take during every phase of development. The very first thing is you do objectives. Determine what are the objectives for this phase. Are there any alternatives? Are there any constraints? And you do this for every phase, for requirements, design, and so on. Then you evaluate the risks. And you do a lot of risk analysis, which means you need risk analysis experts. You evaluate alternatives. Oh, if we implement it on this platform versus this platform, what are the trade-offs? And you resolve the risks as much as you can. Then you do the development or do whatever the activity is at that phase and verify it. And then lastly, you plan. You do a review status and plan the next phase. And you keep doing this for every single phase until you're done. Very what we call heavyweight, very heavy-handed. But in a case where you really need the software, it's important that you hit every requirement, that it's built a certain way. This may be something that's critical to do. Examples of things like where this would be useful would be like, let's take like a missile guidance system, right? You don't want somebody doing a missile guidance system using agile development necessarily, right? What you want to do is, with that, you really want to make sure it works. So that means that you really want to build in a lot of QA and you want to build in a lot of risk analysis to ensure that all the decisions you make are critical, because if you make a mistake, the difference between it working and not working could be multiple lives lost, right? Or more. So so in cases where the margin for error is small and the impact of the error is huge, doing things in a more heavyweight approach is important. Yeah, exactly. So you're doing way more you're doing way more at every step to ensure high quality, right? So you're not just saying, okay, well, here are my requirements. You're actually saying, okay, well, this was a requirement. Do I need this requirement? What are the risks if I don't follow this requirement? If I, what are and so you go through everything. So aerospace would be another example where this could be, useful. And we'll talk a little bit actually later about some of the development with NASA and some of these, because that's actually super interesting as well. Aerospace, aviation, nuclear, there are a whole bunch of industries where the requirements are pretty standard, where the requirements don't change significantly, and where there is high risk involved. What we call those systems is actually what we call safety critical systems. So safety critical systems are systems in which an error or a bug could actually cause a substantial injury or loss of life. So those are things where you really want to actually be sure that you're doing it properly, right? And the risk associated with an error in a nuclear power plant software versus in in a mobile app game, like you're not talking about the same thing. Someone mentioned here the James Webb Telescope. That's a great example. Here's another thing that's super interesting that comes up is if you think about the time, let's take like a Mars rover or something, right? That actually has to go out into space, and that has to travel from here to Mars, right? That whole timeline, I forget the exact amount of time, but we're not talking like days or weeks or months. I think it's a couple years, I believe. 17 years. Good enough. Is that how long? Oh, for James Webb. Yeah. But I'm talking about like Mars rovers. We're talking a significant amount of time as well to get to Mars. So one of the things that actually happens is the hardware and everything gets built. Is it 6 months now? Cool. But one of the things that often you see is actually software updates. So while it's traveling, they may still be writing software. And then the software goes onto the system while it's in transit, which is kind of interesting. You can do that with some of it. Okay, so that's a little bit about the spiral model, and as I mentioned, it's more of a meta model. It sits on top of another model. Every layer is one phase. I already went through these 4 steps. The point here, though, is that every 4 of these steps is about risk and about quality, right? Determining objectives is about identifying potential risks associated with every option and every alternative. Assessing and reducing risk is about minimizing risk. Develop and validate, you want to actually often, if it's a safety critical system, like I said, you're going to want to use formal mathematical approaches in addition to just simply testing. With review and plan, you're drawing up plans and documenting it so that it can be evaluated for risk at the next phase. So these are all steps that have it. Now, this very heavyweight, as I mentioned, it's a meta model, but it's really about finding potential problems as early as possible. So this can lead to really high quality products, but the type of system that needs this heavyweight process is not every system. The other thing is it requires considerable expertise. It needs, how many of you have done a course on risk analysis? I would say none of you, right? And I wouldn't consider myself an expert on that either. But that's the kind of thing. You need people who have actually studied and understand risk analysis and assessment. And if you don't have the right people, this whole thing doesn't work. You also need expertise in terms of all the team members to understand that. So this is something you want to have, this is something you'll probably, I would say most of you will never do in your development, but it's useful to know. Would we be doing some risk analysis in this course? Not for our project. No, we're not going to be focusing on safety critical software. But that is something, if you did a course in further along, not necessarily at our university, but in a graduate level that was focused on safety critical software or what's called formal software methods, then you would actually probably touch on some risk analysis. But that's not something typically we would cover in an SQA course. We would cover more the standard methods that are utilized more broadly in all types of software systems. So one last thing I want to mention is this idea of iterative development. And this is the last one I'll really sort of mention today. And the thing I want to get across to you about iterative development is now we're starting to get to the point where we can actually talk about agile and where we can get to agile. And iterative development is based on subsets. So unlike remember with the evolutionary prototyping, right? What you were doing was you were trying to build an initial version that did almost everything mocked up, and you were gradually filling in the pieces. So I guess one analogy of this between the difference between iterative development and the evolutionary prototyping is that if you think about evolutionary prototyping, if you think about the software system as an image, right? In evolutionary prototyping, your very first version tries to have a rough version of the entire image, right? So if I'm doing a self-portrait, my first version is a stick figure of myself, right? And gradually I add in features, I start to do, and then maybe I'll do shading, then I'll add in colors. And so I'm gradually adding in features for the entire image. That's the more idea of evolutionary prototyping. In the idea of iterative development, I'm doing it in pieces. So I might take if I'm doing a self-portrait of myself, I might take the image of myself, divide it up into, this is not how artists would do this, obviously, but I take it and almost divide it up into a grid of 16, 4x4 pieces, and I'm going to do the first one first, then I'll do the second one, then I'll do the third, fourth, and so on. And that's how I would do it, right? And that sort of gives you a little bit of a perspective. So you build it in little subsets of functionality rather than trying to do the entire thing and improve its function, improve the entire thing over time. So you begin with a subset of requirements and develop a subset of the software product, and you satisfy immediate needs of the user. So this is also an example of, with iterative, if you're talking about, if someone said to you, do a self-portrait, well, if it's an image and you've got different pieces you were filling in, you would probably do the squares covering the face first, because the face is probably the most important part of an image of a self-portrait, right? The background around the sides could be done later. So that's the kind of decisions you make in iterative development. You identify the requirements that are most important for the user, and then you add the other ones later. And over time, you can refine this through iteratives, and you can also meet evolving needs, right? As you do some features, you're going to get feedback from the customer in the same way you'll get feedback when you do evolutionary, and you can take that and you can improve as well. And this is sort of the idea here with iterative development, right? And in iterative development, you do the requirements, you do the design. Now, this is the thing that's sort of you do early. They recommend you do sort of the architecting of the system first before you get into the iterations, because if you just start building a little subset pieces and adding to it, right? What you could get is something that is not really great, right? Is not a great architecture. Take the analogy of, like, if I told you to build a university building and I said, okay, first build a building with one room, then add a second room, then add a third room, a fourth room, a fifth room, and at the end you add 150 rooms. If you didn't know you were going to have 150 rooms at the beginning, you might have a pretty wonky shaped looking building, right? So it's sort of one of those things where you want to have a general architecture first and understanding of the requirements, and then you can add pieces to it as you go. So you sort of have a plan, but then you know that the plan can evolve. And for each time you do an iteration, you develop a certain part, you test it, you integrate it with what you've done previously, and you get a release, you get user feedback, and eventually when the whole thing is done, you've got your full release and you can move into the evolutionary part of this. And that's sort of how iterative works. And this is the closest to getting to agile now. We're getting into the agile idea, and we'll talk about that next class. Before we go, though, I do want to point out that there are some drawbacks to iterative. One of them is that it typically works best with small teams. because if you notice here, each time we're going through an iteration, we're building something and integrating, right? It doesn't have the idea of, oh, well, 6 different teams can build 6 different subsets and put them all together at the same time, right? It's a one at a time process, and that means that it works best with smaller teams. The other thing is a drawback is it needs an early architecture. So it requires that architecture early and to be decided, which can be challenging if the requirements are evolving, because the architecture may not fit the end need sometimes, and that's a risk. However, if the architecture is done properly, it could actually produce a very high quality product. Okay, so that's what I wanted to cover today. I try to keep this lecture a little bit short because I know that the traditional software process can be a little bit dry material. But the real thing that I want you to take out of this is that I want you to have a common understanding about how development has evolved over time to where we are today. And I want you to understand that at each type of process, right, doing waterfall versus prototyping versus iterative, what really ensures quality in all of these things is putting in is that you're following. You want to, those are the things you're trying to do. Like if I'm trying to build something with waterfall, that's the know what you're doing, know what you should be doing. That's what you should be doing is waterfall. How you're actually doing it and how close it is to waterfall, that's the knowing what you're doing, and then measuring the differences, understanding how close you are to the goal you have. But with each of these processes, the process itself is not enough to ensure quality. You also, on top of it, always have to have quality controls at every phase to ensure you're doing things properly. And you want to do it at every phase, because if you don't review the requirements and the requirements are wrong, it's way more expensive to fix them when you've already implemented them than if you just simply had found out they were wrong and fixed the requirements before you do any design. So I want you to understand about the quality control and the importance of that. I see a question here. For unit testing, are we just going to go through shell command unit testing? Also, are they approached the same way for all systems for web dev? And then there's a question for web dev. So we're going to be getting to, and I said testing is actually going to be probably 40 to 50% of the course. So we're going to do at least 4 weeks, if not more, I mean, probably 5 weeks of testing. We will be doing unit testing. We'll be covering unit testing in the lectures. You'll also be doing unit testing in your project. In your project, depending on, in the past, like last time I taught this course, we did the unit testing it happened to be with Java, and we did using JUnit, which is a testing framework for unit testing of Java. If you're doing a different language, there are different approaches to that. There are different tool pipelines for doing different types of testing. Sometimes when you're doing testing in general, you may have to build your own in-house solutions. You may do things at the command line. Other times you may be doing the testing using existing third-party testing tools or GUI-based testing tools. It really depends, and it can vary from company to company. So the goal I have is to sort of show you a variety of different things so that you have a little bit of an understanding. In this course, we're not going to specifically focus on web dev in terms of web development testing tools, although what I'm going to try to do is I actually I know somebody who's a web development tester here in Toronto, and I've actually reached out to see if we can get him in to talk one day about testing as it applies to his position in terms of web development, and I'd like to do that after we cover the fundamentals of testing, so you can then ask questions like, okay, well, how do you do unit testing in your web development? How do you do this? What kind of tools do you use? Because the tool chain and that you use for development in web is very different than the tool chain you would use if you were doing C++ or C or something like that. I hope that answers your question. Any other questions before we end for the day? Seeing none. Oh, yeah, I should mention as well, right now there isn't going to be specifically labs. We're not going to start the labs next week.